Hi, this is Richard C. I'm a math tutor here at Wyzant, answering a question submitted by a student. It's pretty clear this student is taking Precalculus at the moment. This is where vectors are covered for most people. This is what they're studying in Precalculus. So let me just move this back over and draw a line under it. Okay, so we just have two vectors to consider. This first one didn't come out too well. This is I plus the square root. I'll just call square root of 3 times j. Okay, so you just have to remember I is the unit vector in the horizontal. So here's I. It has, you can think of it as 1, 0. And j up here is the unit vector. By unit vector, I mean it has a length of 1. So this would be 0, 1, and that's j. And we can put vector symbols over them to remind you that those are vectors. Okay, so this is pretty straightforward. Let's do part A first. So we're moving 1 to the right and then root 3 up. So let's just draw a right triangle here. This is a 1 and this is root 3. Okay, so we need to find this direction angle here. So we can look at various things here, either sine, cosine, tangent. We can find the distance, this length of the vector here. Vectors are usually indicated with an arrow. So if we wanted to find the length here, the length squared would equal to 3 plus 1, so that's 4. So this would be 2 here. And you should recognize this as a 30, 60, 90 triangle, which is the best way to do it. So let me just remind you what a 30, 60, 90 looks like. So here's, put the 60 here and the 30 here. So this is A, this is 2A, this is A root 3. So you can see that we've got a 30, 60, 90 here where A is 1. So theta in this case is just 60 degrees. And chances are your teacher wants everything in radians, so it would be pi over 3 radians. Okay, let's look at the next one. So this is 5, negative 5. So our angle is going to be in the 4th quadrant here. Here's theta. And this is 5 here, negative 5 here. Okay. Once again, we refer back to the special right triangles. And we'll look at the 45, 45, 90 now. 45, 45. That's A root 2. So if we wanted, we can see that A is just 5 here. And I'll just change color so I could put this as, if I wanted the hypotenuse, it's 5 root 2. This is called the magnitude of the vector. So when we're in vector world, this is called the magnitude. So this vector would have a magnitude of 2, but it's really just Pythagorean theorem, and it really is just length. And then this would have a length of 5 root 2. So this has a length of 2, or magnitude of 2, and this has a magnitude of 5 root 2. So you can see right away that our angle here, the reference angle here is 45 degrees, so which is pi over 4. So theta, if we were doing this in degrees, it would be 360 minus 45. So that would be 315 degrees. Because you could travel all the way around. Imagine traveling all the way around to 360 and then backing it up 15. Backing it up 45. So you go all the way around to 360 and then back down 45 degrees. If we want that in radians, we do the same thing. It's just going to be 2 pi minus pi over 4. So that's 8 pi over 4 minus pi over 4. So it's 7 pi over 4. Either way. Now you should either have memorized your special right triangles or your unit circle. Either way would be the approach to take to doing this problem. I prefer to work with special right triangles. That's just my personal preference. If you know the unit circle, memorize the unit circle, both of these angles, the pi over 3 and the 7 pi over 4, both of these angles appear on the unit circle diagram. So that's all you have to do here. And you're just getting started with vectors. So just, try to get used to them. It does take a little while, especially when you're first seeing them for the first time. It can be a little intimidating, but it's really not so bad once you get used to it. Okay, I hope that was helpful. I'll see you again next time. Bye-bye.